Hello everyone, my name is Ben Davidson. Currently we are in Barberton, Ohio, being hosted by the Barberton Herald. We are on a nationwide and Canada tour with the Mobile Observatory Project, trying to share some of our research and a little bit of knowledge about the sun. This is obviously not the sun, it is a ball, but it'll do for right now. So this thing that is bright and up in the sky does a lot more than give us light. There's something very important that most people probably should know about. It's very fascinating, and it plays integral roles in the weather, climate, even things like earthquakes. And we're not going to go much further than just the basics today, but we'll tell you where you can go and learn more about that. So, here's our sun. And the first question that most people ask is, what is space weather? Very simply, just as the sun, the planets, the moon, anything with mass has gravity that pulls in, down towards it. It's what keeps your feet on the ground. The sun also has an outward force. It's strongly magnetic, and it pushes mostly charged particles and some neutral particles as well out from it in all directions. This is called the solar wind. The solar wind comes off pretty constantly, and it is mostly charged hydrogen, although there are statistically significant amounts of helium and many of the other known elements as well in very small amounts. Now, that's basic space weather, and most of it has to do with the solar wind and changes in the solar wind. Now, what you couldn't see on that sun ball were sunspots. Sunspots are areas where magnetic fields of the sun, remember it's strongly magnetic, come down and poke out of the visible surface of the sun, known as the photosphere. And where this happens, we get these dark sunspots. Sorry, I've got to bend it like that. And what's interesting is we have many different satellites that look at the sun in very different ways. One of them shows the sun kind of looking like this. Apologies for the glare there. But as you can see, as I tilt back and forth, some of these bright areas are very connected to where the sunspots are. Those magnetic fields hold charged particles, and they are also the primary driver of space weather. Now, oftentimes on the sun, when there are a lot of sunspots, the sun will unleash something called a solar flare. That is when these magnetic fields interact and they unleash X-ray and extreme ultraviolet radiation. Now when this happens, they can enhance the solar wind such that we get really dense, really fast bursts of charged particles within the normal steady stream. Now these things are what cause the northern lights, or the auroras. There are actually auroras down south as well, called the Aurorus australis. And the stronger the solar wind impact from these events, the more bright, brilliant the northern lights and the southern lights will be. Now back in 1859, there was an event known as the Carrington Event, a solar flare so strong that unleashed such strong solar wind that swept past our planet that it actually induced ground currents through the auroras, such that transformers today would have been significantly damaged. Now back in 1859, there were no major power grids, there were no large transformers, there was pretty much little more than just telegraph wires, but even those were greatly affected. The telegraph wires caught on fire, the telegraph operators actually got shocked, and a few of the offices actually caught on fire. Now we haven't seen anything anywhere near that since then, but we have seen a few less intense events. In 1989, there was a great Quebec blackout in Quebec, Canada, and this was directly caused by a solar flare and its effects on the planet. In 2003, this happened again in Sweden and parts of Norway. A very strong solar flare came by, the solar wind intensified, and electric currents were induced on the planet that did some damage and knocked out power in those regions. If you were to go on any internet search engine right now and search for something like NASA 2012 solar superstorm, you're going to find quite a few articles about just a massive solar event. It could have been like the 1859 event, except it came off of a different part of the sun. If you are looking at me from the Earth, it came from, back here and it went out this way. So Earth was not really in jeopardy from this event, but it brought into perspective just how vulnerable the planet Earth is to space weather. Some estimates say that in our lifetimes, we could see another one of those massive events, and it could be as high as a 10% chance or more that we could see them. Now, on our YouTube channel, Suspicious Observers, or on our website, suspiciousobservers.org, you can learn a lot about how these things take place, the intricate details of how this would occur, and some of the effects that could take place within our power grid and how that might affect our lives. But keeping things simple just for now, I want to make a quick mention about how the sun affects our climate, our weather. First things first, pollution is a very, very serious problem. Humans absolutely have an effect on climate change, and there's really nobody that should deny that. As I apologize, there's some sort of emergency happening behind me. It's all right. But that notwithstanding, we're left with a problem because the projections of global warming have now essentially failed for 15, 17 years. And we're learning that our mathematical models do not exactly match what we observe. And so the question is, what are they missing? Starting with the premise that indeed humans affect climate change, and we need to do something about pollution fairly quickly for a number of reasons, not all of them having to do with the climate. Well, the question is, what could they be missing? Very simply, this is a chart of sunspot numbers, those things that we pointed out before, that cause space weather and that increase the ultraviolet, extreme ultraviolet, and X-ray radiation that Earth receives from the sun. Now, I added the parts in blue and in red, but everything in black is from NASA's Marshall Space Flight Center, one of the official keepers of the sunspot number. And as you can see, it was very, very cold back when the sun was sort of asleep, if you will, during a grand minimum, what is commonly called the Maunder minimum, named after the husband and wife team with the last name Maunder, who significantly studied and gave us a lot of the information that we know about the Maunder minimum. And then the sun slowly crept out of Maunder minimum, crept up and up and up, and the highest solar activity of the last 400 years occurred directly during the major global warming period. Now, as you can see over here, the solar cycles are beginning to decrease in strength, and there's a lot of speculation that this could continue. Since the 15 to 17 year pause in global warming, this global warming pause, pretty much right on time with when the sun started weakening from this high point during global warming. Now, it's not just sunspots that are following this pattern. The ultraviolet light, the extreme ultraviolet light, those things seem to follow this exact pattern as well. And scientists from all over the world are studying and discovering new ways that we never knew before, exactly how the sun affects our weather and our climate, from all the way up at the top of the atmosphere, even down to where the clouds are, oftentimes by those strongest events, those solar flares. In fact, we were reading an article just last night from way back in 2007 from NASA about how we found evidence in the sediment of the Nile River that shows a deep, long-term climate connection to the sun. And again, on our YouTube channel, Suspicious Observers, or at suspiciousobservers.org, you can learn a lot more about this. This is space weather. This is how it affects our planet. And it's going to be very, very important and prevalent in science in the coming years. And that's vital if we want to understand exactly why our projections of global warming have been off. We can't say that we're out of the woods, and nobody should use these 15 to 17 years of a lack of global warming to say that, oh, human pollution doesn't matter. It certainly does. It's just that we don't have all the answers. We're not perfect. And we're slowly, bit by bit, trying to fill in the gaps and complete the puzzle. Now, we're going to take some questions now that we have the basics out of the way. If we go ahead and put some of the comments up there so I can see them and see some of the questions being asked. Oh, terrific. There's a bunch of them there. Ah, good question from Cameron there. Is there a way I could print out that chart? Absolutely. I assume you're talking about this one. If you were to Google official sunspot numbers, or maybe even just sunspot numbers, and you click on images so that you get the images, you'll probably come up with this somewhere on the page. If you'd like to be a little bit more specific, Google official sunspot numbers and then NASA Marshall Space Flight Center, which you see down there at the bottom. You'll find it very quickly, and you can print that out along with a number of other good charts. A lot of happy comments, but not many questions yet. Oh, and Spud King 009. Yes, your guess is correct. That graph, along with many other ones, can be found on our website, but just as easily found on the internet, even on sites that aren't directly from NASA. A lot of people have pulled these charts and made them available. This has really undergone a huge jump in popularity, if you will. A lot of people are interested in this. Even when our at the time, best solar satellite ever went up into space about 15, 20 years ago, there were still only a couple thousand people in the world that were really interested in this. At this point, we have 187,000 people that just watch our analysis at our channel. And there's millions more worldwide, thanks to people like Dr. Tony Phillips, who runs spaceweather.com and is also a staple at NASA. Thank you, Berta. How to become as awesome as you. That's very kind. We put out a free show on the internet every single day. If you just Google suspicious observers, I'm willing to bet you don't even get all the way through the word suspicious before the search engine will just guess that you're looking for this. Every day at about 6:30, sometimes a little earlier, sometimes a little later, we will put out a show that describes the current state of the space weather, and we often give tidbits about what else is going on. And when I say every day, I do mean every day. We haven't taken a day off since 2011. Holidays, weekends, my mom's birthday. My parents are in the crowd, by the way. Thank you guys for coming. It's been a while since I've been close enough to home for them to visit. And so if the sun comes up, you can be sure our news is coming out. Grandpa D. Matt, will you do a video on how to protect ourselves from flares, like a Faraday cage? Well, myself, maybe, maybe not. However, there is a man named Billy Yelverton. On YouTube, his channel is Mr. Too Tough 2, and he and I work together a lot. He's a great man and a good friend of mine. He has built many Faraday cages, and I'm willing to bet he'd be willing to share his knowledge with the rest of us. Joseph Brownell, can this pollution be converted to energy for us? In fact, there's a lot of people who try to do that. There are many more theories and hypotheses about how this could be done than what is actually in practice. And I would consider that a very, very benign effort if we were to try to do that. Wow. Questions flying. Yin Yang Mind. What got you started on this research path? Well, I started after high school. I went to Penn State University, and among other courses, I took a couple meteorology classes and quickly discovered that this wasn't the most sensical way to look at the weather. And I had a couple of friends who worked on climate projections and told me exactly how much they were struggling with them. And so I had this in the back of my mind going forward. I ended up not continuing through with meteorology. I actually went to law school, and a lot of lawyers won't admit this, but we can't memorize every single law. So what they really teach us to do is be research experts, how to find the answers, often complex answers communicated in a complex way, collate the information, and then communicate it back in a way that people can understand. And I got interested in the sun and the weather and the climate once more, and I never looked back. Just decided to put those skills to good use in something I actually am passionate about. Good question from Miguel C. Why do you think the sun will have a minimum? And this is clearly somebody who watches, because I didn't mention that, but it is very possible, in fact, perhaps even probable, that the sun is heading back towards this minimum period right here. Now, without getting too technical, there is a man named Arnab Rai Chowdhury. He's the man who has best predicted the sunspot patterns for the last 10, 20 years or so. And when surveying the last 11,000 years, as best we can, obviously we weren't looking at the sun all the way back then, but using things like ice cores, tree rings, even some of the things we find in rock, we can make pretty good reconstructions. And he's found that about every 400, 407 years, we have a full solar cycle. And that full solar cycle would be a grand minimum, a rise up to grand maximum, and then it starts all over again. So 400 years ago, we were right about here. And we see the sun, again, dropping off very, very quickly in its strength. In fact, very, very good solar scientist named Mike Lockwood states that the sun is now weakening faster than at any other time that we can identify in the last 9,000 years. That, combined with a number of other factors, is why we think the sun really may be headed back here quite soon. Seeing a lot of questions from people who quite clearly are beyond just this beginner level and asking things that are really too difficult to explain in this presentation, like coronal holes, which play a vital role in space weather as well, and actually even in things like earthquakes. Miguel, another good question. Can the minimum be connected to reverse polarity? I'm not sure if you mean reverse polarity on the sun or a magnetic reversal on the planet Earth. However, the sun's magnetic field, the sun has a north and a south pole, just like the Earth does. And it actually flips magnetically every 11 years. Earth's is on a much, much longer time frame. And 400 years ago, when we were in the grand minimum, our poles were just the same as they are now, although there are some indications that our field may be changing slightly. This is from the WDC for Geomagnetism in Kyoto, Japan. This is basically just two frames from an animation they have showing that from the 1600s to about the year 2000, we lost some of the strength of Earth's magnetosphere, the magnetic shield that allows Earth to safely interact with the solar wind without us being blasted by charged particles in the atmosphere getting destroyed. For those who are interested in looking into this a little bit more, we have a video called Magnetic Field in Trouble. Turns out that we've lost about 15% of the strength of this shield, and the European Space Agency's SWARM mission has proven that this trend is beginning to continue. So it's something that's very important for us to monitor going forward. There are a lot of hypothesized effects that this could have on the atmosphere, on the weather, and on earthquakes and volcanoes and things like that. But since none of us have ever seen one, and we just have guesses about what happens in the past, we're kind of entering new territory there. In some ways, in many ways, we can use this 400-year grand solar cycle to make some predictions about what we're about to see. However, 400 years ago at the last grand minimum is when our field began to weaken over here. So there are elements of what we're going through right now that are quite novel. Terrific question from Berta. Is there more to this minimum than we know? Is there a big difference between minimum and maximum? I'm not sure exactly what you're going for there, but the solar minimum and solar maximum in terms of just the regular ultraviolet light that comes off is only about a difference of 0.1%. Now, that doesn't sound like a lot. However, the sunspot numbers can go from 0 up to the 200s or more. And when it comes to those extreme ultraviolet and X-ray events, those can vary by a factor of 10 or more between periods of high solar activity and periods of low solar activity. Francis Stevenson, I would love to go over climate change more and how it differs from the old so-called global warming. There's a huge difference between the global warming that we've all heard about in the news since Al Gore decided to bring it out about 23, 24 years ago, and the very real climate change, extreme climate swings in both directions that we see now. However, that's not really a beginner topic. There's a lot of information on that on the site and on the website. Why do I think events like space weather are not given the consideration they apparently deserve by those who claim CO2 is the single cause of climate change? Well, there could be many different reasons. Don't forget, this is a multi-billion-dollar industry, climate change. But at the same time, they are starting to recognize that, you know, they've made some mistakes in their projections. The sun is becoming a more prominent factor in the minds of a lot of scientists who have been putting out papers in even just the last 18 months or so. And indeed, I have a feeling that as we go forward, they're going to start to figure out exactly how to work the sun in to their climate projections and other things like that. Yes, Cameron, climate change is indeed very, very real. And I would like to reiterate the fact that humans do play a role. Earth is a system, and every input into a system has an effect. I don't really like it when people take the things I say here and try to imply that we shouldn't be worried about pollution, or we don't need to worry about climate change because the global warming projections have been wrong for now almost 2 decades. We don't have all the answers, but one thing that is fairly certain is that this is a major issue and is going to be a major issue for years to come. There are a number of groups who are against this global warming and climate change paradigm for strictly economic purposes, and they try to use the 15, 17 years global projections to try to say that, oh, see, there's no climate change problem. Well, there absolutely is. We just don't have all the answers to it yet. Terrific question from T-Straub90. When we see flares coming off the sun compared to the Earth scale, something I show just about every day on YouTube, it seems like they're moving incredibly fast. How fast do these particles really move when they flare up? Well, the particle bursts come off the sun, and they can be traveling many millions of miles per hour, 1 million, 2 million, maybe even more. When they reach Earth, they're moving significantly slower, but they can still be moving close to 1 million miles an hour. We tend to gauge this stuff in kilometers per second, actually. And when these particles are sweeping past Earth, what we consider just normal, calm solar wind is actually traveling at about 300 to 400 kilometers every second. When we get a strong burst from the sun, they can go up to 500, 600, 700, or maybe even more. Something like the Carrington Event, something that would take out the power of a power grid of a nation or a province, or something that could actually take out the power to the entire planet, would have to be moving significantly faster. We do have evidence that those events have occurred in the past and can occur. One likely occurred in 2012 but came off the backside of the sun from our perspective. They're much rarer events. We don't see them as often. Ray Davies, I would love to answer that question here, but that is way beyond beginner level. And too many cats. That's a good point. One I'm hoping isn't true, but it might be. The fact that they will include the solar effects when they figure out how to tax us for sunlight. That's very, very possible. How do I think we can lessen our impact on the environment? Well, I can only really speak to that from a basic perspective. I'm certainly not an expert in pollution per se, but we do need to be regulating the largest polluters in the world, and not just here, but overseas as well. The United States could completely cut all pollution in the world, and in 10 or 20 years, we might not even notice a difference with how fast things are progressing in China and India and other parts of the planet. J. Good Pasture asks, what is the planetary K index, and does it relate to solar wind at all? There are a lot of solar indices, the A index, the K index. I like to use the KP index, which is directly related to the solar wind and how much it is affecting Earth's magnetosphere at that time. T-Straub90 asks why Helio viewer is down. I'd like to ask that question myself. It's a staple part of the news. It allows us to see the sun in every wavelength that they offer from satellites. It really enhances the news, and they have a nice little Earth scale that they show with it. Unfortunately, it's been down for a couple of days now. Spiritual artist, yes, they are already starting to tax solar panels. Not too long ago, there were intense export and import controls put on all solar panels from China, and this was an odd thing to see from our administration, especially after they backed that one solar company out of California with nearly $1 billion. So it was an interesting flip that we saw at that point. Man, I had no idea you guys would come up with such intelligent questions, and high level too. Remember, this is a beginner video. Grandpa D. Matt, what is my favorite aspect of how we watch the sun? That's easy. It's easy to watch the sun. If you want to just kind of take a minimal approach, you could just watch the news every day on YouTube. At Suspicious Observers, we tend to show the sun in as many wavelengths as we can each day. But more importantly, and most importantly to me, every day, everything I say and everything I show is cited with a hyperlink, with a source directly below the video, so that if you want, you can go find these things for yourself. And on the YouTube channel and on the website, we have a lot of videos that will actually show you how to go onto those websites, navigate them, and do these things for yourself. Self-empowerment, empowering you guys to do this yourselves if you want to is something that I consider equally or perhaps more important than actually the actual reporting I do each day. If you guys can't go verify what I say, if you can't go check these things out for yourself, and if you can't take your learning into your own hands and keep going, then I haven't really done a very good job at all. John, that is something I absolutely can do. Tell us more about changes on the other planets. Believe it or not, climate change is not restricted to the Earth. And it's not even restricted to the sun, if you want to consider sunspots and solar flaring part of the solar climate. You saw on that chart just how much the sun changes even over, a few hundred years. However, just in the time that we've been monitoring Venus, for example, its fastest wind speeds have increased 33%. Now, that's a lot. We have not seen that kind of increase here on our planet. We have set a record for the strongest tropical storm. We have set a record recently for the largest tornado, the strongest tornado, but they weren't 33% stronger. It was just that we kind of crept up over the edge and set a new record. Before this pause in global warming, there was pretty much a tight race between Earth and Mars as to who was warming faster. At this point, Mars is now dominating that. Mars also changing more than the planet Earth. Jupiter. Jupiter's red spot is fading. Red Junior was born on the planet, and there's plenty of storms every day, dozens to look at on Jupiter. Most aren't significant enough to garner a name. Also, there are cloud stripes on Jupiter, and one of them completely disappeared a few years ago. We haven't seen any kind of changes like that. And for as long as we've been able to see Saturn, and it's a lot longer than you might imagine with even some of the earliest telescopes, we've noted a superstorm that appears on Saturn. Every 30 years, like clockwork, we know how big it's supposed to be, when it's coming, and how long it will last. For the first time in the history of human observation, we just broke that pattern. The storm arrived 10 years early, lasted much longer than expected, and was extremely powerful. A good corollary for this would be if like a Category 6 or 7 hurricane, something that we know nothing of at this time, were to hit the east coast of the United States much earlier than it was supposed to, say January 1, but lasted through the summer, or maybe even the whole year. The Sun, Venus, Mars, Jupiter, Saturn, all changing more than our planet is. Clearly, the only thing that could do that is the Sun. And it's another reason why we need to be looking at the Sun to try to fill in the gap in our current climate understanding, to try to figure out exactly why things have gone so wrong the last 15, 17, maybe even up to 20 years. I'm struck with an interesting mix of happiness, pride, and frustration. I want to answer a lot of these questions, especially about Dr. Uyen's concepts. And that's making me very, very happy, and I'm really proud of you guys for getting into that more. And I'm also frustrated because many of the people watching this will not be at the level to understand those just yet. Ray Davies, that goes for you too. Terrific question. For a lot of these questions, what are Earth spots? Earth spots like sunspots. What is the connection between the sun, things like solar flaring, coronal holes, the polar force of the sun, and earthquakes, tropical storms? These are a little bit more complex topics, but these are things that we talk about and explain, and which you can watch happen every single day on the YouTube channel. Of course, we don't take the videos down every day. You can go back as far as you want and see how these concepts and hypotheses are progressing and how they're proving to be very, very fruitful as we go. Miguel, another great point there, talking about the rotation of the planets. Venus and Saturn, so far as we can tell, have actually slowed their rotation speed during this time of global warming, which would be a really nifty trick if our pollution here was causing that all the way out there. Somehow I doubt it. Luca, you make a terrific point. I won't go into it too much. However, the question was, is it possible that government or someone else is somehow trying to protect the Earth from future climate and planetary solar influence? Well, all it takes is an internet search for the word geoengineering or weather modification, and you'll find that, you know, we have been playing with the sky a little bit. In fact, even back as far as the Vietnam War, we were experimenting with things like cloud seeding, sort of the infant first steps, and perhaps they even go back a little earlier than that. And there are many people who take the opinion that that is what is causing all of this climate change and this bad weather here on the planet Earth, them messing with the sky. But you also have to remember that the climate has always been in flux. These changes go back hundreds of years. If you study what a lot of our ancestors described in the climate changes were much, much worse back in the day. And if you spend some time studying the things I've talked about what's happening on the other planets, you know that Earth is really doing better than just about every other celestial body in the solar system. And so there is that question of, are they trying to play God a little bit, if I may use that turn of phrase? Are they trying to stave off some of these greater changes that our ancestors saw and that they think may be coming, like the changes that we see already on the other planets? Unfortunately, it's tough to find truth and a lot of certainty in that realm. It's kind of a wait and see for right now. Daniel Erickson asks if there's been a change in the luminosity of some of the other planets. And I have heard that a number of times. I've heard some conflicting reports as well. It's something I'll look into a little bit more, and I'll try to get back to maybe at a later date. But it definitely has been mentioned. Question there from Mr. Loafer, David Hyde, if you will, who runs our blog, Suspicious Observers Collective. Not really sure that's a beginner's question, buddy, but solar activity and we'll call that solar energy, and energy from the rest of the galaxy appear to be inversely related. So when solar activity is high, the energy intake of the planet from the rest of the galaxy is low, and vice versa. And there's a lot of suggestions that and a lot of observational evidence, not just those mathematical models, which tend to be wrong more often than not, that show that as the sun continues to weaken, as it is doing now, and if we indeed enter a grand minimum, we will have a strong surge in the cosmic radiation, the galactic energy that we take in, which has been as conclusively proven as I think can be to create cloud cover. Now this is something interesting, and this is something that will also need to be worked out in the global warming, climate change models if we want to get the right answer. There's something that they call albedo. It's just a fancy word for reflectivity of the planet. And they're discovering that the more clouds we have, remember, our clouds are white here on Earth, they perfectly reflect light. And so the more clouds we have, the more light is reflected, the cooler it's going to be. This poses an interesting question, at least from my part, because nowhere in there did I see them mention anything about the greenhouse effect, which is supposed to be wholly based on extra cloud cover heating us up. Seems to be the exact opposite. The only explanation I really have in that realm is the fact that they looked at Venus, saw how much carbon dioxide Venus has, saw the fact that Venus is actually hotter than Mercury, and came to the conclusion that it was the carbon dioxide trapping in the heat, the clouds trapping in the heat, and things like that. However, Venus does not have white clouds. It's yellowish, brownish, much more receptive of that light energy, and will trap the heat a bit more. Question, while we were visiting Canada, did my wife and I see the auroras? Unfortunately, we did not. We were hoping to, however, the sun had managed to continue its really weak activity. And we even had a huge spate of sunspots come around the disk. When I say the disk, that would be, the Earth-facing disk. This is clearly round, but from Earth's perspective, we essentially see a circle or a disk. We had some huge sunspots come by, some of the bigger ones that we've seen this entire solar cycle, and yet even with those sunspots there, the sun really failed to produce any significant activity. So no, we didn't get to see any auroras. MRK 102474. By the way, if that's your birthday, our birthdays are 3 days apart. Says, okay, so to put it basically, it is your opinion that we are causing some harm to the Earth, but it's mostly the sun and there isn't anything that can be done to stop that. And we'll actually cut it off after this question, because this is a terrific one on which to end. Pretty much absolutely right. Humans are causing some of this climate change. Our pollution, more so, has a lot of negative health effects, not just on humans, through respiratory, central nervous system, even the endocrine system, but the plants and animals of our planet are being poisoned by this. The air is being poisoned, the water is being poisoned. There's a lot of reasons why we need to take care of pollution and do it quickly. But indeed, it is mostly the sun, and no, there is nothing we can do about it. But before you start to get scared by that proposition, let's say we do come back here. Can anybody tell me anything interesting that happened in between 1600 and 1700? And that was kind of a disingenuous question, as you can't actually talk to me through the screen there. But people that looked kind of like me crossed the Atlantic Ocean and established 13 colonies in the United States. Stuff gets done. A mini ice age is not a full-on ice age, although there are many people who believe that there are a lot of reasons to suggest that a full-on ice age may be coming in the not-too-distant future. However, if we do slip into that mini ice age, there will be some distresses in agriculture, in food growth. Some of the winters, like Europe saw a couple of years ago, and that the United States and Canada saw this past winter, will become more common, more prevalent. The cold will last longer into the spring. Farmers will have to wait longer to plant. There have been some events where large amounts of livestock have unfortunately been lost to the cold, because it was such a late cold event, or even an early cold event, that we hadn't really seen, we hadn't really prepared for. I'll cut it off with this. That multi-billion-dollar business that is climate change, it's one of the biggest businesses on the planet. And there is really no money given to thinking about, studying, planning for, modeling what happens if the Earth gets cooler. I would humbly like to suggest that for every $10 we spend on global warming, let's spend one planning for global cooling. Thanks, everyone. Eyes open. No fear. Be safe.